Hello all, this is Bayshra again, and we're going to continue our short break from turtle mode, and we're going to continue doing a couple more coding experiments. Today we're going to be working on a rectangular prism carver. I'm not really sure the word for it. It's going to act like a quarry where it'll mine every block in an area, whether it's an ore or not, and we can use this to carve out larger rooms and the like. So we can just jump straight into turtle testing, and with the last tutorial, I can just time-lapse through coding, maybe a little of the testing this time, and then I can go through the entire program when I'm done. Oh there, turtle. Okay, so I'm going to start with that now. I will talk to you when I'm finished, I guess. That's, yeah, good enough. Happy watching. Okay, so I have the first part of it done. It can do a 2D plane, should work with any size. It can handle gravel, which is good for underground mining. And now I have to make it 3D, so that'll be fun. I'll talk to you when I'm finished. So something about me adding in 2 more blocks of code caused it to stop working properly. Hopefully I'll have this figured out soon. Be right back. Okay, so I think we got this working now. It should be able to do any size quarry based on your the three user inputs, and it should be able to handle sand and gravel if it encounters any. So we're just going to do one last test here to, I guess, showcase it, and then when we're done, I can start going, if it all works, of course, which I'm hoping it will, considering my tests. If it all works, then I can start going over the code. Now, one of the things it has to do is it has to recognize what it should do at the end of each layer. Now, if it has a even width like this, there's 4 divided by 2, yeah, it's even, it will actually end right here facing this direction. And in this case, we want it to turn to the right, go this way, turn to the right, dig down, and continue. And actually, now that I think about it, it would be more efficient if it would go back. And actually, I'll probably change that. Let me do that real quick, actually. Okay, so I made that edit. I have no idea if I did it correctly, so we actually get to see in this test. And there you have it. It worked. And we can do one or two more tests here to make sure it can do it with all dimensions. But I believe it is now functioning. There is currently some kind of odd bug where when it gets done, if it's even width, when it gets done, it'll dig a block, or yeah, it's just kind of odd sometimes. Yeah, you can see how it went down one from where it should have ended. But that's not too much of a problem, and if you're really concerned about that, you could fix it yourself. Good practice. Okay, so we're going to actually start to go over the code now. So be warned, and you might have skipped past the rest of it to get to here. So let's start. Okay, I would like to first start by saying I didn't make up all of this on the spot. It is all my own. But I actually spent a while writing the code in, middle of class kind of thing. So, yeah. This is a kind of a different argument thing that we did at the beginning here. And it's getting multiple args, so we have to use the curly brackets instead of the parentheses that I normally use, and that makes it a table. And we have a clause here that checks to make sure there's 3 arguments, and if not, it stops the program there. Then we're setting our variables x, y, and z to the 3 inputs, args1, args2, and args3. And then we're going to set a ton of variables for other uses here. We have xt, yt, zt, mt, rotate. And then we also make sure that x, y, and z are all numbers. So we have our while true do. Actually, because of that, it'll keep going until it's done, but I should make sure that it has something over here to stop it from crashing. Okay. So after this, we have several blocks. First of all, we have if zt is equal to z, then it'll end. Alright, so each of these variables, x represents the length, y represents the width, and z represents the height here. ZT, or actually anything that has a T after it, is going to be used for a counter. So in this case, we're using like XT here to count how many blocks it's moved forward, kind of thing. So this will just tell the program to stop once it's done with everything. And actually, I think I have that in one more time, so it's kind of redundant. While xt is less than x, so this is just making it go forward. And actually, there's a lot of extra things that I've added in specifically to work with the gravel and sand. So if it goes forward, then it'll add 1 to xt, and if it didn't go forward, it will do all of this stuff here. Else, I believe it goes down to, yeah. Here, let's actually just work this part out. There we go. And it will then check to see if it's on its first layer, and if it can't go forward, it checks if it's on its first layer, and if it is, it does a loop here, where it will check in front of it, and if there's something in front of it, it will pick up the block or mine it, and then wait 1 second, and then check again. As long as that's true, it will continue to do that. And this only occurs on the first layer because it will only ever encounter falling at gravel or sand on the first layer that it mines, because it starts at the top. Alright, now if it's not on the first layer, it simply just breaks the block. Then we have another counter, MT, and I was lazy, which is always bad. I was lazy with this. I have MT here, which is just about the same as YT, but I add 1 to it at a different point here, which makes everything easier for me. And you'll see what that does. So then we have our rotating here, I believe, yeah. So if it finished its line, if xt is equal to x, and rotate is equal to 0, and previously we set rotate to equal to 0, and yt is less than y, and right now it will be yt once again is the how many blocks wide it's traveled so far. It will do this turn route. So it'll just turn right. It has some stuff to deal with gravel, and yep, and then it'll go forward and turn right. So what'll happen here? It starts. Let's say it starts here, right? It goes forward 1, 2, 3. Rotate is equal to 0, so it turns right. Goes breaks blocks here. Goes forward, turns right, and then it continues with its program. And we actually have to essentially have that twice, because if it's, let's say, over here, it needs to turn left, and that's different. So there's actually essentially 2 copies of that here. And we're also going to switch rotate to the other number, and that makes it so it'll properly rotate the other direction next time. Alright, so we're actually almost done here. So if mt is equal to y, so if it's done going its width, and rotate is equal to 0, then it will, and zt is less than z, of course. It will do this string here. And actually, I believe these last 2 blocks are our return blocks. And they're what triggers the next layer, essentially. They reset a ton of values, and they move the turtle back. So in this case, mt is equal to y, rotate is equal to 0, and zt is less than z. So we start here with, we start here with rotate equal to 0. It goes all the way to here. Rotate is now 1. We go over to here, rotate is now 0. And yeah, so we're going to end here right now. So rotate is equal to 0, let's just say. And what it's going to do is, it will, wait, is that right? 1 second. Something's wrong here. Oh, I think I have the rotate backwards. I think that must be it. Okay. The code is correct. For some reason I'm just having troubles wrapping my mind around what I just typed, which is always an interesting experience. Alright, so starting here, it's equal to 0, equal to 1. Oh, okay. So right here it's equal to 1. We want it to be equal to 0 again. So we end up being here. There we go. Now the code says, if we go, let's see, where are we? So the code says it will turn right. Oh wait, sorry, wrong area. So rotate is equal to 0 here. There we are. It will, so it's right here, it'll dig down, it will move down, and then it will turn around, reset its variables, and then it will add one to or to its height, or ZT, and then it will start its process again. And if rotate is equal to 1, which means that it's an even, it's mined even wide here. So, you know, it's 0, now it's 1. Instead, it will simply, let's see, what does it do here? It should go back, I think. 1 second. Rotate is equal to 1. Oh, whoops. I keep going over there for some reason. Rotate is equal to 1. Here we are. It sets this variable reset, which is only used here, to 1. And pretty much it will go from here, and it'll go back to here. When it's done with that, it goes down, resets its variables, adds 1 to ZT, and starts on its way. So the result of all of this is that we can easily specify any dimension area to be carved out. Now, this isn't ideal for mining. There are more optimal ways to mine an area out, which I might be getting into later. But this is mainly for carving out rooms, and for now I can use it for mining, because it is just going to be really much simpler than anything else. As always, it's going to be available on the pastebin page, and I will talk to you next time.